Good morning, everybody. I hope you had a good night's sleep, ideally with AC. Who didn't have AC? Oh, but most of you did. Okay, that's good, that's good. So you are prepared for another day of talks, great talks. We will kick off with another Troopers veteran. You are here for the 6th time, I think. Yep. So quite a few years. So that's great. And I think you will talk about your journey and will show us that our cloud infrastructure is just as fragile as our naming conventions for files. So let's hear it for I'm in your cloud v4 final PDF.
Good morning. So this talk is going to be a little bit of a story, which is also why it says like the V4 final. We'll get into that, but I hope this is going to be my final I'm on your cloud talk. I don't think, and I hope for Microsoft that I'm never going to top this. But before we kick off, a little bit about me. So I'm Dirk-Jan, I'm from The Hague. I work at this very small company called Outsider Security. It's just me doing freelance stuff. I give talks, I give training, I do consulting, and of course also a bit of research. As already mentioned, not my first time at Troopers. I like to do research, to write tools, to publish blog posts, and to talk about it at conferences. I have some socials if you want to keep up to date with my new research. But I don't really want to talk about me too much today. I do want to talk a bit about like the story behind the discovery of actor tokens and the big vulnerability. So we're going to talk about how it started, and then about a few iterations of the research, how I discovered actor tokens, that I didn't really know what to do with it, so I paused it for a while, then revisited the topic, and then in the end, spoiler alert, we're going to hypothetically hack every Entra tenant in the world. But as I mentioned, it's a bit of a backstory. So the first, like I'm on your cloud talk was in 2019, or at least the first 3 actually of these talks were in 2019. I wasn't sure I was going to do a V4 in 2026, but here we are. But in 2019, my first conference talk actually was here at Troopers, the I'm in your cloud reading everybody's email. So I'm curious, who was here in 2019 at Troopers? Who was there at this talk? Ah, a few people. So it was my first talk, and I first entered the room, and I saw, oh, well, the room is not too big, that's great. Then I saw who was sitting in the room, and I was more for my first talk, and I saw like all the people from the Bloodhound that made Bloodhound, like Will, Lee, Rohan, Andy, Sean Metcalf was there, Benjamin Delphi was there. So basically everyone whose blog post I ever read was there for my first talk. I was like, okay, no pressure. Anyway, so I had my first talk about Entra, and in that talk I had a few questions, and things were not really clear, like how everything worked, like I knew nothing about it back in the day. So a lot of question marks that we slowly answered. And actually for this talk I've also copied some slides over that are still quite relevant for this research. So in that talk in 2019, I made this very beautiful graphic about like exploring the paths from on-prem Active Directory to Azure Active Directory, as it was still called in the days. So my assumption was that there was some kind of security boundary between the two, that just because you compromised on-prem AD doesn't automatically mean that you can also compromise Azure AD or Entra. I've kind of assumed that these would be separate and there would be some security between them. So there has never been an official word from Microsoft that this is a security boundary, but they did harden the boundary quite a bit over the years, so I think it was a valid research target. And we're actually going to go back to this today. Now, in this talk in 2019, I mostly talked about Azure AD Connect. Now it's called Entra Connect Sync. And before this talk, like a long time ago, this was running as global admin. Now if you have something that's on-prem that runs as global admin, then of course it's not very hard to lateral movement to the cloud. But when I gave this talk, when I did this original research, it was running with the directory synchronization accounts role. So you could do quite a few things with that. Actually, the first vulnerability that I ever found in Entra was that it could also overwrite the passwords of global admins, or even cloud-only accounts. That was my first AD bug back in the day. But this service, this Entra Connect Sync service, this directory synchronization account roles, it had quite a few documented permissions. And perhaps the most well-known is the fact that it could update service principals, add credentials to service principals. So kind of automatically this meant that if you had a service principal with privileged rights, like a service principal with global admin equivalent permissions, by definition you could go from on-prem to the cloud and compromise these service principals. So that was not, it was documented, so it was not rocket science. So that was my first talk at Troopers. Then I guess the I'm Your Cloud V3 was at Blue Hat in Seattle later that year. And there I explored a few more documented things. And the one that kind of piqued my interest was this policies action. So if we go back to the documentation, we see that this account is allowed to create, delete, and update policies. The problem that I always have with these rights in Entra is that it's kind of vague. It doesn't really tell you, like, okay, what exactly can I do with this? Like, what are policies in this case? In order to figure that out, I had to find like a sort of secret version of the Azure AD graph. It was the 1.61 internal version. I've had a lot of fun with that API over the years, especially back in 2019. But at the time, like there wasn't really a way to modify policies via an official API. Like policies, probably the most well-known policies are conditional access policies. But at the time, it simply said like, hey, there is no graph API for configuring conditional access. It just doesn't exist. And indeed, if you went to the official version of the Azure AD graph at the time, the 1.6 version, and you queried like the policies endpoint, you got like 0 results. So nothing was available there. If you switch over to the undocumented internal version, then suddenly you were seeing the policies. So then we were looking at the conditional access policies. The curious case is also that any user could query these conditional access policies. That's actually still the case. They never really changed that. I guess they're waiting for the Azure AD graph to be completely deprecated with that. But with this internal API, we could in fact modify policies. You could delete policies. So if you were like, well, we have MFA, so if you compromise an account on-prem, you cannot use it in the cloud. The sync account could just delete your MFA policy or change it. But it was all back in 2019. Technically, this was documented, like the ability to modify service principals, the ability to delete and modify policies was documented. So I reported that to Microsoft. They did make some changes because you could also make hidden changes to policies with this API. That was also interesting. But they never fixed the fact that this sync account could modify these policies until like 2023. Only then did they make that change, and they blocked basically apps from, or they blocked the sync API and even global admins from modifying policies via the Azure AD graph. However, these were not the only policies that we have. So if you ever run Road Recon, then of course there's the UI for Road Recon, but there's also the database. And in the database, you can see the actual objects. And if you go to this policies table, then there is a large list of all the policies, which includes the conditional access policies. But those are not the only policies. And basically anything that's in this database table, which comes from the policies endpoint that I showed you a screenshot before, could be modified. And they fix it for conditional access policies, but not for all of these other policies. So in the years after, I did a bit of research into what these other policies were. And one of them is called the on-premise authentication flow policies. And this actually stores the seamless single sign-on settings if you have that. Pass-through authentication configuration if you're using that. It stores the password management policy where you can modify like how self-service password reset works. There's also some kind of vague names which are called default policy, but then you have to look at the policy type to know exactly what they do. This stores your authentication methods. And there's also the external identities policy, which stores your B2B collaboration settings. There's a few more, but these ones I found the most interesting. So after the like 2019, looking at this API, I looked a bit more at these APIs over a few years. And in 2023, I discovered that I could actually add like additional seamless single sign-on keys by modifying that policy. So if you weren't using seamless single sign-on, then you could actually, from the sync account, provision seamless single sign-on, add your own like keys, and then you could also authenticate with that method. And normally you would need global admin to configure seamless single sign-on, but the sync account could do it over the undocumented API by modifying the policies. This was technically documented because the documentation said it can modify all the policies, just nobody knew what that exactly meant. So I didn't really disclose this because seamless single sign-on is also only first factor, and of course, well, in 2023, maybe not everybody had it yet, but most people were luckily enforcing multi-factor authentication already at the time. So I was like, okay, let's also try to figure out how I can actually bypass multi-factor authentication rather than only single factor. That took another year. But in 2024, Microsoft introduced support for external authentication methods. So then you can basically implement your own external authentication provider, or you can use like a third-party provider like Duo or Okta or something else that supports basically this protocol. And these are stored on the authentication methods policy. And the interesting thing about the authentication methods, the external authentication methods, is that if you put people in scope of that, then you can actually use it to bypass their multi-factor. So all the normal authentication methods, like if I modify the FIDO configuration, I can change it, of course. I can put admins in scope of FIDO, but it's not automatically going to provision a FIDO key for these admins. However, if I configure an external method, and because this is like an OpenID Connect-based protocol, I can just create my own fake external provider, and that will then pretend that I did multi-factor. So this is the only one that I know of that allows you to comply with the MFA requirements just by putting people in scope of that policy. All the other ones you would first need to configure the authentication method, which we didn't have the rights for. So that also solved the kind of multi-factor authentication thing. So in the end, I ended up with like several methods to do these things and to kind of extend the lateral movement. But at the time, like there were other techniques. So the service principal way, the ability to modify condition access policies, okay, that they patched. But all these like weird corner cases that you could backdoor these policies via the internal API, technically they were documented, so I didn't really consider these bugs. And I'm the kind of person that if I know one way to achieve a certain goal, I'm not very interested in exploring like all the other ways to do the same thing, because if there's one method and Microsoft considers it by design, why would I bother with all the other methods? So I didn't really do anything with this. I just kept it for like later, maybe it's going to be useful. And I shelved it for some later point. Then we moved to 2024. So in 2024, a few things changed. And it's one person who is kind of related with that. So in early 2024, our friend Nestory actually joined Microsoft. Now, for those who don't know, like he did a lot of research on this Entra Connect, like with this internal API that it uses and a lot of attack paths. And when he joined Microsoft, then he started making some noise internally about fixing some things related with that. So in August 2024, Microsoft changed the permissions of the sync account, and like with one action, they killed kind of all my attack paths, because like none of the permissions were there anymore. It could no longer modify service principals. In fact, it could no longer modify any objects via the graph. The only thing it was still allowed to do, as Nestory points out, is that it can like read and modify the synchronization API. So I had all these techniques, and especially some techniques that I thought were kind of fun, that I never really had the chance to talk about, that were now suddenly fixed. So previously it was all like, not a problem, you can do this, and then suddenly it was a problem, so they fixed all of that. And then I was like, okay, but now if it's a problem, or if this is actually security boundary, and you're fixing all my previous things, now I'm actually motivated to find some new things. Of course, I had to go back to zero. because all my other techniques were fixed. So I was thinking back about like what else could possibly run on-prem that goes to the cloud, because the scenario was still like, if I compromise the on-prem environment, can I move to Entra? So what else could we possibly have that is placed on-prem and it has some privileges in Entra, or at least talks to Entra, maybe a privileged account. And then I remembered that also, like back in 2019, or maybe a bit after, I got an assignment to kind of review a hybrid Exchange environment. And what they had was that there were some mailboxes that were hosted on-prem and some were hosted in the cloud, and that kind of was interconnected. So back in that review, I noticed something interesting. That was that basically the local URLs, like the on-prem URLs, were configured on the Exchange Service Principal. So this is a screenshot from RoadRecon. Here we see the Microsoft Service Principal for Exchange Online. So this represents the Microsoft cloud version of Exchange. However, it does have like on-prem redirect URLs or reply URLs. So this means that you can actually do OAuth with the same service principal as in the cloud, but then also on-prem. This was interesting, first of all, because I didn't even know you could have different redirect URLs on a service principal than the official one in the Microsoft site, but apparently that's possible. Second of all, is that this has some consequences. So I was like, okay, the Exchange Online Service Principal has some redirect URLs that are pointing to an on-prem server. So that's probably for making it possible to do OAuth against the on-prem Exchange. It's one of the features of hybrid Exchange that you can do. However, since Exchange in this case is a website, websites need to they act as confidential OAuth clients, which basically means that they need to use a client secret or certificate to complete the OAuth flow. And if you have a client secret, I mean, that must be stored on that server, because that server is then completing the flow on-prem. And of course, I can also use that client secret to authenticate as that service principal with the client credentials flow. So it's not only possible to authenticate users locally, but also to authenticate as Exchange. So we can actually authenticate as Exchange online from on-prem AD, most likely, because if this OAuth flow works, then there have to be some credentials. Luckily, we can see which credentials exist on the service principal. So if you just go to the key credentials on the service principal, you would see some certificates. And that means that there's probably a private key somewhere stored on that Exchange server that makes this whole thing possible. So we had on-prem stored credentials on the Exchange Online Service Principal. So basically, if we could compromise Exchange on-prem, and the starting point was that we did compromise the on-prem domain, so then it's not super hard to get admin rights on the Exchange server. We could potentially obtain the shared the credentials of that shared service principal and authenticate as Exchange Online. And if you know a bit about the Microsoft world, then Microsoft service principals often are super privileged, so this could be quite powerful. A few more challenges. So we do have to obtain these credentials. This turned out to be slightly easier than expected, because I could just remote desktop to the Exchange server. I could click on export. And the installer didn't even bother marking the private key as non-exportable. So just by clicking on things, I could export it, didn't even need to run any tools. Doesn't really make a difference, because unless you store this in hardware, you can always export the private key. But this is kind of making it really easy. So then I had an Exchange certificate. And I could use that to authenticate. And I actually wanted to make sure that my hybrid setup was working, which was kind of the hardest part of this talk. I don't think I ever got the full Exchange hybrid working. But there was this nice commandlet to kind of test at least if it worked in my lab, this test OAuth connectivity. And I got it working far enough that this command returned success. So I tested the OAuth connectivity with the EWS service on the online version of Exchange, like the outlook.office.com, and apparently my on-prem Exchange could talk to Exchange Online because the result was success. This commandlet also has some very interesting debug information. So if you store that output, then you can see like what exactly it's doing underwater. And that was quite a curious case. So I saw like all the details, and then I saw a lot of things that I never heard of. So it's authenticating to the outlook.office.com, and then it's prompted for authentication, obviously. But then one of the authentication service that it can use, so Exchange has a list of like valid authentication services that it considers. It's called ACS in my tenant, because this is my tenant ID. And it's going to talk to that ACS, and it's getting an app token there. So I never heard of ACS, and this was like in 2024, 2025, when I already had quite a few years experience with Entra. So if I never heard about something, then it's probably interesting. And then at ACS, it was getting this thing called an actor token. Don't know what it is either. That request looks like this. So if you're familiar with like OAuth, then this is not exactly how Entra does OAuth. Like first of all, it goes to the OAuth/2 endpoint. That's not something you normally see. It's using the ground type JSON Web Token 1.0/bearer. And the resource is also a bit different because it uses both a GUID and a URL and then adds the tenant ID. So this is not exactly a standard OAuth flow in Entra. They will look a bit different. But it's basically authenticating with that certificate that we have. So then we receive our actor token, or access token as it's called here, but it's actually an actor token. We'll get into that, what that actually is. So then we get a token. This is very similar to how Entra does it. But with that actor token, it was doing some further steps. It was embedding that in a JSON Web Token with the super secure signing algorithm of none. Well, that's kind of like a flag, like something weird's going on here. So it was using that actor token inside another token that was unsigned. So I was staring at this a little bit. And if you've been doing research for a long time, so maybe some pen testers here or red teamers, they'll kind of recognize this feeling. If you start like an assignment, you're reviewing an app or you're pen testing an app, and at some point you're like, this app feels kind of weird. There's something wrong with here. You can't quite point your finger on it yet, but it just feels broken. And that's kind of the feeling that I had when I started looking at these actor tokens. Like none of this was documented. This was just screaming like legacy, legacy, legacy everywhere. And like there has to be something here. This cannot possibly be implemented completely correctly. So I did some more digging to figure out how this actually worked. So it turns out that Exchange kind of uses this to, in this case, the on-prem Exchange uses it to talk to Exchange online. So you would think that if Exchange wants to talk to the cloud, it talks to Entra, but it doesn't. I mean, it probably does now, but at the time it didn't. It talks to the service called ACS, or the Access Control Service, as it apparently stands for, which is even older than Entra. I still found some blog post that says, oh yeah, we're deprecating ACS in favor of Azure AD, or something like that, along those lines. So that's kind of how old that is. Way before I started looking at this. So what Exchange does, it requests an actor token from this ACS service, and it issues this token, so this is based on the certificate. And with that actor token, as the name implies, it can act on behalf of other people. So if I say, okay, I want to act on behalf of Bob, I can talk to Exchange Online with my actor token and say I want to impersonate Bob, or Alice, or basically anybody, because this actor token is valid for anybody in the tenant. So if I want to access data that's online hosted, I can do this with the actor token. There also was some interesting data on this ACS service, so I still have this URL on here. You could actually see all the domains in the tenant, even after Microsoft patched the previous way to see those, but they actually fixed it, so you can no longer see the domains there, unfortunately for the red teamers. But it was basically was there still for like half a year after they blocked the auto-discover trick. Anyway, actor tokens. So this is how actor tokens look, or the decoded version of actor tokens. We see the audience. So this is Exchange Online with that GUID and outlook.office.com. It's issued by Entra, so it kind of identifies Entra by its GUID. And then the interesting part, which makes these tokens so powerful, is this flag trusted for delegation. So if the trusted for delegation was true, then you could use this to impersonate anybody in your tenant, in the tenant. If this is false, then it was not allowed to impersonate users with this token. So this actor token is signed, and we use it, we embed it inside a unsigned token. So this is the signed part, and the rest is not signed. And in the unsigned part, we basically say, I want to impersonate this user. So you just specify the user principal name, and then you can send this token to Exchange online and access anybody's mail. So with the compromised Exchange hybrid on-prem, so if we manage to compromise that, then we can actually pivot to Exchange Online, and we could pretend to be any user. For some reason, Exchange also had unrestricted access to SharePoint. I don't know why that was needed, but you could also just request access tokens for SharePoint. So then basically you could access any file in SharePoint or in OneDrive, which is also SharePoint, or any mail in Exchange. I have a demo for this. So the demo does use SharePoint. Reason for that is that with SharePoint, there's a nice trick to actually use these tokens in a UI. Always makes for a bit nicer demos than calling an API. So let's see if the video wants to work today. Yeah, so I'm going to request my actor token. So it's going to be for OneDrive, so the -my.sharepoint.com. And then with that token, I'm going to locally create a impersonation token to basically access the files of a specific user. And by default, it's defaulting to this account. This is actually a global admin. So now we're accessing the OneDrive of a global admin, but it doesn't really matter which user because any user is valid. So this is the OneDrive of this user. And then offline, I could just swap out that username in the token, and I can say I now want to do it for a different user. Then we generate the token locally, we do the exact same trick, and then we'll be looking at somebody else's OneDrive. So you could also talk to the API and like exfiltrate all these files, but like I said, the UI just makes for a bit nicer demo. You could also do this for the SharePoint Admin Center. So if you impersonated the global admin, like SharePoint Admin Center is also kind of an instance of SharePoint, so then you could also manage the entirety of SharePoint. So a lot of attack surface there. So basically, Exchange and SharePoint were kind of done. These actor tokens, the official name for them is service-to-service tokens, or at least that's what Microsoft calls them in the few bits that they have documented about this. These have some very interesting properties. They're valid for an entire day. So once you have that actor token, you can do whatever you like for a day. You cannot revoke these tokens, like there's no way to revoke them. I mean, you're not even going to know that they exist because there's no logs when they're issued either. So they're just like secret tokens. The unsigned part we generated locally. If I generate something locally, of course, that's also not going to leave any logs in Entra. The only part where you would see any logs is if I access data. So if I access files, then you see like, okay, the files were accessed in the Office activity logs and things. But the interesting thing is because we are impersonating Exchange, and if you use that token to access mail, then it looks like the user was accessing their own mail because Exchange is impersonating that user. So even if you have logs, it's still tricky to detect kind of abuse with this. So it's valid for anybody in the tenant with the trusted for delegation flag. And these tokens like completely bypass all possible security measures. So no conditional access, no security checks, no access checks whatsoever, basically, because these are supposed to be kind of backend tokens. So when I researched this, there were a few apps that were allowed to do this. So I found these like 5 apps, and what these all have in common is that there is some on-prem variant that you can run for this, and that's why they still allow this. Now, historically, you could add credentials to almost all Microsoft service principals. That's also something I talked about in 2019, and that other people also talked about after, but they hardened that quite a bit, so now the list was down to 5. But probably, like, if I would have tested this in 2019, then probably I could do this for hundreds of Microsoft apps, and all of these would be allowed to get these actor tokens, because Microsoft actually uses this in the backend. So in the cloud part, in the hidden part that Microsoft doesn't tell us how it works, whenever Exchange, for example, would talk to SharePoint, it would like impersonate the user with these actor tokens. So it's kind of like a backend flow that they kind of put in our on-prem environment as well, with if you have the Exchange hybrid setup. Curiously, around the same time as I was researching this, or at least when I was preparing a talk about these actor tokens, Microsoft also released a blog on that they were actually fixing part of this, that they were hardening this. So if you look here, then they talk about these service-to-service tokens and high privileged access with these impersonation rights. Of course, nobody knows what any of this means, but it's quite a dangerous thing. And they mentioned that they successfully mitigated more than 1,000 of these scenarios, which kind of supports my theory that probably, like, historically every single app in the Microsoft backend was like throwing these tokens around that can impersonate an entire tenant at the time, like they're like some kind of free cookies or something like that. So they mitigated a lot of this. This blog, of course, didn't mention how many of these scenarios they still had left. I know that now they've mitigated even more because I did some testing and I couldn't see the actor token usage anymore in some services that were previously using it. But they were also aware internally that this was maybe kind of not the best concept ever. Anyway, so I was able to, from on-prem, access Exchange Online and SharePoint. But I was feeling that like there has to be a bit more with this. So, of course, I only have a certificate on the Exchange Service Principle in my tenant. Microsoft has one that's valid in every tenant. So I was thinking, like, if I can somehow compromise like my Exchange Online instance, then maybe I can also access that certificate. Maybe I can use that to get some cross-tenant access. Like, I don't know if this is true. Probably there has to be some way that it can access tokens. I don't know how many layers of there are in between, like the Exchange front end and the backend token. And the big problem with trying to test this is that you need an Exchange RCE, which I didn't have, and I don't quite have the skills to find one either. It's not my area of expertise. Historically, there have been Exchange RCEs that you could use in your own tenant, because of course, if you spin up a test tenant, you do get global admin, which means you can do quite a few operations against like semi-shared Exchange instances. So there have been Exchange RCEs that may have been, that could maybe have been used to test this idea, but I didn't have one of these. So I kind of put this on the shelf because I was feeling there has to be something more useful about this, but I didn't quite know what yet. So then we go to 2025. And always at the start of the year, you have to think about, like, okay, what kind of research do I want to talk about this year at conferences? Because most conferences have their CFP very long in advance. So I was like, okay, I'm just going to make a talk for Black Hat and DEF CON because Microsoft fixed all of my previous findings. So I can talk about that, about some historical attack surface, and I can also include the new actor token part, talking about Exchange and SharePoint, because it's kind of interesting enough. So I submitted those talks to Black Hat and DEF CON. They were accepted. So I was like, okay, let's make the story. And in June or July, I was kind of preparing my slides and making my scripts a little bit nicer so you can make a few screenshots. And I was starting to do a bit more testing around this. So one of the things that I actually didn't test originally, which was kind of an obvious thing to test, but I don't know why I didn't do it, was requesting a token with the Exchange certificate for the Microsoft graph. I don't know why I didn't do that earlier, but I requested one, and I saw it had quite a few privileges. The most interesting here probably being the domain read-write-all. Because what this allows you to do is to configure custom domains in your tenant. You can remove domains. And also, federation information is also configured on domains. So if you can modify domains, you can also change domains to be federated. You can add your own federation certificate. You can add backdoor certificates if it's already a federated domain. If you hardened your federation setup and you don't accept MFA claims from on-prem, then you can also change that setting back to the insecure state, and then you can also bypass multi-factor authentication. So this kind of increased the impact a little bit because now we could actually like kind of add federation backdoors, and this will get you like quite high privileged access in most Entra tenants, unless it's super hardened and they really have good separation of their accounts. Then might not get you global admin, but in most tenants I have seen, this can probably get you global admin. Okay, a bit more powerful, but this is the rights that are assigned to Exchange, so it's interesting, but not a clear vulnerability. Then later in July, I was like, well, why would I not like request a token for my favorite API, the Azure AD graph, the graph.windows.net? because I looked at Exchange, I looked at SharePoint. I couldn't request these actor tokens for the Microsoft graph, or at least I don't think the Microsoft graph accepted them. But why not test it for the Azure AD graph? So I requested a token. I received one for graph.windows.net with the very interesting flag, trusted for delegation true. So that made it quite a bit more powerful. So now I created my actor token for the graph.windows.net. Or sorry, I created my impersonation token with the actor token embedded for graph.windows.net. And I tried to access the graph API. I did need to fix one more thing. So the graph API actually doesn't care about the user principal name. Exchange and SharePoint do, but the graph API doesn't. The graph API only cares about this thing called the name ID, also sometimes called the net ID. This is kind of some old artifact, I believe, from like the Windows Live days, that at some point they merged into Entra. This is basically an internal identifier that Microsoft uses for your accounts. So if you look at again, Road Recon, you can see this actually on the user account. It's called the net ID. You can also see it in any tokens that you get, but this is basically the identifier that you use with this. So if you query this net ID of a global admin, which Exchange can actually do, then you can put that in your impersonation token, and you can impersonate anybody and talk to the graph.windows.net. Now, if you can impersonate anybody in graph.windows.net, that's quite a bit more significant than being able to talk to Exchange and SharePoint, because graph.windows.net, even though it's a legacy API, you can basically manage everything in Entra with that. So you can create users, you can make them global admin, you can modify conditional access policies, even though they fixed that. Exchange impersonating global admins could actually modify conditional access policies, while the global admin directly couldn't do it. And this bypassed all the possible security controls. So then I was like, okay, I cannot really not disclose this, because this is quite a bit more powerful than the previous impact. So I'm like, okay, I'm just going to give MSRC a heads up, like, hey, this actor token thing, it's not really great design that you have. And while writing my report, creating a proof of concept for MSRC, improving my script, I'm like, okay, let's try a few more things just for fun. They are probably never going to work. And what I did is that I tried to just change the tenant ID, because like this part is not signed. So this, I can put whatever I like here. So I started like fuzzing it a little bit, like see what else weird stuff I can put in here. So I had this signed actor token from my test tenant, and I changed the tenant ID to a different tenant. And this is actually my real tenant. So this is where I do my work, read my mail. I chose that tenant because I'm pretty sure I don't have any relation between my test tenant and my prod tenant. I really try to keep these separate. So I was not expecting this to work, and I swapped out the tenant ID. And indeed, it didn't work. So I got an error message. I didn't quite expect this error message, because what it said user was not found. So it didn't say like, hey, your token is kind of weird, like there's a tenant ID which doesn't match. It said the user was not found. And that made sense, because I didn't change the net ID. So the net ID was still pointing to a user in my dev tenant, which clearly didn't exist in my real tenant. So I looked up my net ID. I just looked at the token. So again, this is my real user account that I use for my daily work. I copied the net ID to that other token. I reran the same query. I don't have a screenshot of that, unfortunately, but I was querying the policies endpoint, so I swapped out the net ID, and then suddenly I was looking at my own conditional access policies. From a completely different tenant, I was able to query data in my tenant. Okay, that sounds kind of weird. I did want to make sure that I didn't accidentally create like a relationship between those tenants. So I did a few more tests. So one thing I tested is that I also had my user as a guest user in a different tenant. And with that user, I could query the net ID of a global admin. So here I'm impersonating my own account in that other tenant, basically another development tenant that I have. And then I query the username of an admin that I know. So then we get their net ID. So my net ID ends with FD08. Their net ID is with F571. So F571, I put that in a new token. So this is my net ID. This is a different tenant. This is the target user. I swap that in the token. So you see now it's F571. And I use that to query all the users in the tenant, which as a guest you cannot do, but the global admin can obviously do that. And I saw the whole list of users. So that worked. just to test a few more things, I also ran road recon because road recon uses this API, and you see it was able to like query everything in the tenant without any errors whatsoever. So all the data in the tenant could be read with this like cross-tenant token. And it's not only read access because you can also write things over this. So basically, you could kind of do this cross-tenant. I also made a video of that that was in the same tenant. This was the video I made for MSRC as a proof of concept. But you could actually do this in any tenant. And this video adds like a new global admin in the tenant just for demonstration purposes. So I impersonate global admin, and this script adds a new global admin user. So it creates a user, gives them global admin rights. And we can then sign in to admin.microsoft.com. Username, passwords. And then we're signed in. And let's search for that. Hey, there's a new user. And it is, in fact, global admin. So we just used the token, we targeted someone else's tenant, and we just added a new global admin, and then we're global admin basically in any tenant in the world. So that was kind of how I felt, like, oh, this is quite nice. I also felt there were a few more feelings, a bit of stress. So I have a smartwatch, it tracks your stress levels, and you can identify the exact time where I found this vulnerability. Because after that, my stress levels were kind of high. Like, I didn't really want this responsibility. I'm like, well, I kind of want to, like, the first instinct is like, oh yeah, I want to share this with everybody just because I'm very excited about this. And the second thing was, it's probably better if nobody knows about this because I don't want people showing up at my door and asking for like vulnerabilities and stuff. So I wanted to report this to Microsoft as fast as possible to get my stress levels a bit down again. So I submitted this report with this very subtle title. I'm like, well, if it's going to be a report, I might as well just make it very clear to them this is very serious. After I submitted this report, then I started thinking about, okay, what are the prerequisites for this? Because I told Microsoft, like, you need to know the net ID. There's probably ways to obtain that, but you probably want to fix this as soon as possible anyway, even if you cannot get the net ID. But then I was thinking about, okay, what ways do I have to actually figure all of these things out? So we need two things, the tenant ID and a net ID. Now, a tenant ID is very easy because you can query those based on the domain name. So if I know which company I want to compromise, I can figure out their tenant ID very easy. Net IDs are a bit harder because these are not public. But I did come up with a few strategies. So I already mentioned the part where you can see them in tokens. So if you ever posted a token anywhere on the internet, even expired tokens, your net ID is in there, and that would have been enough to compromise your tenant. But I wasn't actually very motivated to go scouting for tokens on the internet. You could also actually just brute force them, because net IDs, unlike object IDs, they're not random GUIDs, they're sequential. So they increment with every new user that gets created. Which means that the larger a tenant, like if you have 100,000 users in your tenant, it doesn't take that long to find a valid net ID. And that brute forcing doesn't leave any traces because you're just reading data. And at the time, the Azure AD graph didn't have any logging. So you could just brute force your way through and probably get access to any tenant that way. I looked a little bit at like how many net IDs there were in between my tenant and some of the other tenants I had access to, and it ranged from like 100,000 to a few million or sometimes a billion. So it was sometimes quite a few requests, but it's definitely feasible if you really want to compromise specific tenants. But then I thought about a much more efficient way to do this, and that is over B2B trusts. So this actually goes back to 2022. Then I did a talk at Black Hat on guest users. And these are some slides from that talk. So in that talk, I explored like how guest users are linked to like the guest account in other tenants. So if you are invited as a guest, then you have your home tenant where your like home account exists, and then you get a guest user in what's called the resource tenant. So if I invite you, then you get a guest account in my tenant. Now, how are these two linked together? that turns out to be based on the net ID. We can see that in the alternative security IDs, this is a different format, so it's base64 encoded instead of like ASCII encoded. But if we decode it with CyberChef, you see that this is, again, a net ID, and then we can see the net ID of the user. It matches with the alternative security ID on the guest user. So basically, how this link is established is that your net ID in your home tenant is the same as the alternative security ID in the tenant where you're a guest. So with this knowledge, we could actually kind of abuse this, which means that if you had an account in my tenant, I knew your alternative security ID, and I can actually use that to compromise your entire tenant, because you have a full account in your home tenant, which means I can query all the global admins there, then I can impersonate the global admin, and then I have control over the tenant. So everybody who ever accepted an invite into my tenant was kind of automatically compromised. But in any case, if you like brute force your way into one single tenant, then you can from there compromise all of their guest users. And the interesting thing is that this goes like against the direction of invite. So I invite somebody and then I compromise their tenant after that. So it's not the guest user that's the problem this time, it's where you have a guest user that's the problem. So I theorized this a little bit, how this would work. Basically, you would start in one tenant, and then from there you could compromise basically all the tenants where that they had guest users from. I looked at a couple of tenants, and it ranged from like 5 different tenants in one tenant. I looked at to like 120 in some other tenants, because the more guests you invite, basically the more companies you could compromise from there. So from one tenant you could compromise a few more tenants. There you can kind of repeat the whole thing, compromise more tenants, and if you look at this, you might notice that this like scales kind of exponentially. So the more tenants you compromise, the more tenants you can compromise after that. So of course, I never really tested this because that would not be very legal. But with this, you could probably compromise like 90% of all the Entra tenants, like in less than an hour, because you only need one token to do all of this. The rest of the tokens, you just generate them locally. So this would very, very fast compromise like almost every tenant, except the tenants where they don't have guest users, or they don't invite anybody, or they don't allow people to be invited from their tenant. Also, if you start at one tenant, there is one tenant that you'll very quickly compromise after that. Anybody wants to take a guess? Microsoft. Yes, so Microsoft also does a lot of consulting, and then what happens is that a Microsoft person gets invited to the tenant of their customer. So with some tenants that I had previously reviewed, I found like at least 50 people from Microsoft, which means I knew their net ID, which means it's very easy to compromise Microsoft's tenant. Of course, once you compromise Microsoft's tenant, like a lot of people are given guest accounts in the Microsoft tenant, like MSPs, MVPs, which means that you compromise most service providers. From the service providers, you can also compromise their customers, because you can also see net IDs, for example, in Sentinel or things like that. It also gets recorded there. So this is quite a powerful technique. So again, sad I never got to test this, how fast this would go, but I'm pretty sure it would go very, very fast. There's some good news, and that is that if you actually abuse this for anything other than reading information, then of course you would get audit logs. So once you start adding global admins and other people's tenants, it's not super stealthy. The audit logs are also kind of weird, or at least not very subtle, because they have this weird artifact that in the Entra audit logs, it kind of combines the display name of Exchange, which we were impersonating, with the user principal name of the one we impersonated. So Entra isn't sure anymore who actually did this action, so it kind of combines like Exchange with that user, because Exchange was impersonating that user. Again, only reading information didn't leave any traces, but modifying it did. If we actually look at the Cloud App Events, there we can see a bit more of the picture. So Cloud App Events is less confused. Cloud App Events knows that it's actually both my user, even as my net ID, and Exchange acting at the same time. So it correctly recognized that Exchange was impersonating my user. So this was a kind of an interesting way to detect that. So there's this very kind of short disclosure timeline. on July 12th, I found this, that actor tokens worked on the Azure AD graph. I think that was in a weekend. On Monday, I found that it actually could be used cross-tenant, which also means on Monday I reported it to MSRC. MSRC did recognize that this was potentially quite serious, quite fast, so they opened the case the same day. The next day, I actually did the other research, like how to find net IDs, and I added that to the report. Like, hey, I previously didn't know how to get these net IDs, but here are some techniques for that. The response to that was that they requested me kindly, can you please stop testing this? Because they were probably concerned about too much noise being in their logs, because I'm pretty sure they wanted to analyze whether other people were also doing this and abusing this. So I stopped testing at that point. And 2 days later, they actually pushed a fix for this. So that's like a timeline of 3 days between reporting it and fixing it. Within the Microsoft world, it's like extremely fast. It's kind of like they patched it the day before I reported it, if you know how slow Microsoft can be sometimes. It took a while for that message to propagate to me, so I only found this out on the week after. Also, they were quite a bit concerned about the whole actor token bit. Like even the not cross-tenant bit, they weren't very happy with. So in August 6th, which was the week of Black Hat, I think this was the day before my Black Hat talk, or 2 days before, they actually kind of started blocking actor tokens altogether, at least for the Azure AD graph. So if you have credentials on the service principal, then you're no longer allowed to request these tokens for the Azure AD graph. They after also blocked it for just requesting any token for the graph whatsoever. There were more people not very happy with the whole actor token story. So the day after, CISA also published a emergency directive like, hey, if you have the Exchange hybrid with the shared service principle, you want to migrate away from that, because otherwise anybody can pivot between your on-prem mail and your cloud mail. So they weren't very happy with it either. And September 4th, they issued a CVE with like a CVSS 10 score, or not initially with a CVSS 10 score, but then they changed it because it was quite a bad thing. And September 17th, I released this the blog post. So I did a bit more testing, earlier this month, to see what else they changed. So the whole shared service principle, that was already something that Microsoft wanted to move away from, because again, they kind of realized that probably wasn't the best design in the first place. So they already announced the split service principle model for Exchange, in I think it's April 2025, and since October that's now mandatory. So you cannot use the same service principle anymore in Exchange on-premise in the cloud. And I also tested a bit more with actor tokens, but Exchange Online and SharePoint Online both did not accept my actor tokens anymore. And also, Microsoft seems to be using the actor tokens less in their backend, because I didn't see any traces anymore. Because before, if you connected to Exchange Online and you modified groups in the Exchange Online PowerShell, then you could see that in the backend it was using an actor token to do that. And now it's using some kind of different mechanism based on the telemetry that you see in the events. So they kind of killed off all my techniques again, but this time it's fine, because I was very happy that this one was fixed. So this was hopefully the last edition of I'm Your Cloud. I'm sure I'll find more Entra stuff eventually, but with this journey with AD to Entra, I think I've now kind of covered all the techniques, and it's not going to get any better or worse depending on which side you're on anyway. So thanks for being there, especially the people that were there all the way from 2019 all the way to the end. And I'd be happy to take any questions you might have.
Thanks for the talk.
No problem.
So sometimes, even though sometimes it seems questionable, at the end of the day, I don't have any doubt that Microsoft is employing some world-class engineers. So I have a hard time imagining that none of them have seen this coming. And I'm wondering if you have any insight or any theories how you, as an outsider or someone who's not working at Microsoft, managed to find this, and how they could blunder it so badly.
Yeah, so I didn't mention this, but what is a bit a recurring theme in this talk is that like in 2019, like nobody really cared about security. Like you see that all these things that were just by design, all these permissions that it had, which weren't even needed. So almost none of the permissions were actually used, but they were still there, and they were kind of like, yeah, we cannot be bothered with that. And ACS, that's even like a more legacy thing that they probably just didn't have any priorities to migrate away from it. So I think it's more a question of time and priorities. And it's no big secret that Microsoft for many years just prioritized new features over security, which is also why like the CISA gave them like a big slap, like you should be doing security now because your culture is very bad around that. And since then they have improved with like the Secure Future initiative, and they actually started prioritizing security, which is why you also saw that they were actually working on reducing this high privilege access, because probably was one of the points that they highlighted, like this is like a bad design and we should stop using that. So just a question of priorities, and probably people knew it was bad, but like I can imagine that the lines of code that were like wrong with this. So they just checked the tenant ID in the wrong place. They checked it from the unsigned part instead of the signed part. That's like a very small mistake, which is quite critical in this case, but it's not like it's some huge design flaw that they consciously made. It's just like one tiny mistake that they checked it from the wrong place and never noticed that it was actually checking it from an unverified part. So it's probably not an engineering problem, more a priority problem, and small mistakes can happen. And then if you have such a protocol that's super powerful and a high risk that they were consciously using, then it has a huge impact. So I hope that answers the question.
Any other questions?
Thank you. Do we know if somebody else actually used that? Did they disclose something about it, some information?
So Microsoft said that as far as they know, nobody abused this. I don't know how much they know, how much telemetry they have. That can be left to interpretation. If there's no traces of abuse, it either means there's no abuse or that there are no traces. We don't know, but I mean, I think that if this was abused, then it would have shown up at some point, because it does leave very specific telemetry. So if a threat actor would have abused this to like add global admins to a tenant, that wouldn't have been very like stealthy. So at least modifications were quite visible. So unless a threat actor only did the discovery part and left everything else like there, I don't think this was abused, because like we've seen threat actors actually abuse things like that. So it's not like they want to save it on some point. If they have a technique, they just use it, like we saw with the stolen signing keys, etc. So probably nobody has abused it. It's also like it also took me, with all my previous Entra experience, like a long time to find this, and even to realize like the full potential of this, because I also, the first time I didn't really see it, and only the second time I realized and kind of luckily tested like this one like weird thing that I never expected to work. So even though it is in hindsight quite an obvious thing to test, it takes a long time before you get to the point where that's an obvious thing to test. So I don't think it was abused.
Yeah, thank you. One question, would this also be possible, or do you imagine this would be possible to pivot from the normal public Entra environment to these somehow disjunct clouds like the US cloud, government cloud, or even the ones operated in Germany or in China?
Yeah, so the sovereign clouds, they have their own signing keys. So if they have fully separate signing keys, then this would not work, because this was still signed with the Entra signing keys. There is one exception to that. So the US Gov Cloud, it like uses both signing keys, because you can have like cross-cloud collaboration. So maybe it would have worked there. I didn't test it. So it's hypothetical, but the cloud instances that have like only their own token signing keys there, it wouldn't have worked for sure. The other ones, I don't know, we'll never know.
Okay, great. If you have more questions, Dirk-Jan will be around, so find him.